question that you guys remember or have these written down from last week. And if you're like me, this negative sign blends into the fraction bar and I lose it. If they ask you to do the derivative of cosine inverse and it's negative, whatever the pattern was for sine inverse. Derivative of tangent inverse, well, cotangent inverse is negative, whatever the tangent was. Secant, they're not gonna ask you these two. But, and remember the way I remember them, sine begins with S, so there's a square root, a squared, and a subtract. You learn sine first, so the sine, the one goes up front. Tangent, no S, the T looks like a plus, but there's no square root, no subtract, there is a square, figure that one out. They love this one, you need to know it. Like all over the place, you need to know it. And just because it goes with the story, secant, there's a square root, a squared, and a subtract, because it begins with S. We did not learn it first, so the one is in the back, and secant sucks. Jill bars. So, I proved those derivative patterns last week by doing this differentiation. Basically, you need to know those two. Questions? Because we now need to do regular old inverse. We did get through this part with straight lines, right? And we figured out that the derivative of an inverse was just the reciprocal slope. And then we got to this scary looking thing, which I don't work with that at all. The way I look at these, so the rise and the run, the y's and the x's, they trade places. Function at A is B. So the inverse at B is A. I always write those two things out. So Michael, if the derivative at A is 7/5, what do I know about the inverse?
It's going to be reciprocal of the root.
Where?
At 7/5, at x plus 7/5, y by 3. Or y is still 3.
Okay. So f prime of A is 7/5. What do I know about G? Specifically, give me a coordinate, and G prime of
Use 5, 7.
unless it's linear, it might be 5/7 only at one specific spot. You need to be clear about it. So this I have trouble saying. Am I talking about the x value, the y value, this guy's x value, that guy's x value, which one? So I always write these out. So try finding the slope of x squared at 2 and finding the slope of its inverse at its respective coordinate. Tally their receipts. sit with the class. Compare the slope of f at x equals 2. So what is, Franco, how do I find the slope of f at 2?
I did like, what do you call it? Power. Yeah, power law.
Okay. So what am I gonna say?
F and then the line x. Yeah.
F
Equals
prime?
2x. Yeah, F prime.
And how do I find f prime at 2?
Plugging 2 for x, so you get 4.
Okay. How do I find the inverse? George, what do I do to find the inverse?
Did you take the reciprocal?
It's not reciprocal. I want to find the function that is the inverse. So in algebra 2, what did we do to find inverse?
Oh, you switched it to one.
Trade the x and the y. So, and I'm gonna call it g of x, because I get confused otherwise. So how do I get g of x all alone? Sadie, what do I do to undo squared? Square root. So the inverse is square root. Adrian, what's the derivative of g of x?
That's 1/2 x to the negative 1/2.
Okay. All right, now they asked for the slope of inverse at 4. Slope of the inverse at 4 is 1/4. I didn't quite show that the function at 2 is 4, the inverse at 4 is 2. How they trade. And it looks really clear. This guy's rise and run switch. It's not negative reciprocals, they're just reciprocals for the inverses. And this is usually just a little trinket thing, they rarely ask about it, and Roman, your brother, over Zoom was like, no, wait! And held me on Zoom 10 minutes after I really wanted to hang up to be like, I don't remember that thing, it's gonna be there, I know. And then he stayed on Zoom the next time and was like, it's there. I answered his question, he took fine, he's on the wall. But he was like that inverse thing. There it is. So, with that, answer that question. Oh my God, it's just alphabet soup. Ray, what coordinate do we know on the function?
3, 5.
So Naomi, what coordinate do I know on the inverse?
G of 5 is
G of 5 is 3. The the x and the y trade. Kyle, do I know the slope on f or the slope on the inverse?
No.
I don't know either one. I'm not given a derivative at some.
Or yeah, you already got 3.
For which function, the f or
For
f
f,
inverse?
yeah.
Okay, so the derivative at 3 is 6. So Kari, I know the derivative on the inverse is what?
6.
G prime at this guy's x value is the reciprocal. Lynn, does that make any sense? Yeah. This is always like, Sorry? G prime of 5 is, that's the only thing I can tell you. I can't tell you anything else about F or G, F or F inverse. They told me one spot. Okay, Katie, what's,
Where did the 5 from in G prime?
okay. Well, first off, as inverses, like with the x and x squared and square root of x, if f has the coordinate 3, 5, doesn't the inverse have to have the coordinate 5, 3? Okay, so that's where this comes from.
Right.
And so given x squared, we did the derivative there. At the inverse's counterpart point, so the x and the y trade, this rise over run becomes this guy's rise over run. Just the reciprocal. So let's look at it again. So the slope of the original function at the original function's coordinate was 6. So counterpart function, it's this guy's x value, that guy's y value is this guy's x value, and that's the thing that hurts. I don't know how to explain that well. So this is why I always write these two first. Okay, this guy's x is that guy's y. The slope at this guy's x is 6. So Kari says the inverse's slope at its x, which is that guy's y, is the 5th. Yeah. Now we're getting it. Happy Monday. That's the way Delta Math says these. So Franco, what's our first line of defense?
Have to write it down.
Writing it down might be a good idea. Jason, what do I need to do to figure this out?
You need to take the derivative of
Okay, so what is f prime?
negative 3x squared plus 6x squared 6.
Cameron, where do I need the slope of my original function? What x value? At 1. And what is the slope at 1? So what is the slope, Stella, of my inverse at -4, which seems to have nothing to do with x equals 1? whole like concept dyslexia thing, turn things upside down, and I'm like, wait, I was supposed to turn it upside down, so am I tricking myself, or is this okay? Alright, so, back in the old days, these are not great. These are questions from all of the inverses from past AP exams, which they're not great. I have a worksheet of new forms of torture. Yahoo! So it's just 5 questions, work with your partner. And otherwise, you can use the rest of class to do the rest of the 2-day assignment, and we will talk about all the homework from 3.7 and 3.8 tomorrow.
Attendance guy was in the office, but it's wait, so like this now. Yeah, it is 1 I thought the 2-day assignment was just what it said on one day. Yeah, I was pretty confused, which I just said it was just one. Yeah, and then I went into the it's like 1 through 21. They're on this, so that's why.
Yeah.
I didn't get,
So you 22, 23.
Okay.
What? You 22 and 23. Yeah, or whatever it was. I thought it was 21.
Did I?
21 to 26. Wait, so Amelia, that one, well, yeah, it says 2 days and take 22 says. So it's what we did yesterday, but on phone. Yeah, I know, but it's like a 2-day thing.
The derivative over one.
But it's just the, wait, it's just the 1 through 21, I feel like. Yeah.
So, guys, textbook homework is that 2-day assignment. This is the second day of that 2 days. It's page 162. Amelia, it was 1 to 21, every other odd?
Yeah.
There's an Ann. Oh no.
So it's just, you know, there's a lot, number.
Okay, guys, those of you who had a question on number 4. Alright, so there was a question like this on the last test. One, to check to see if you could do systems of equations, but also to see if you could do continuity and differentiability. This is multiple choice, so you don't need to show all this work. On a free response like what I gave, you did. So for something to be continuous, the limit from the left and the right at the place where this breaks needs to equal the function at that place. So they're setting this up, plugging in x is 1/2, which this doesn't show well up here, so, well. This side, a times arctan of, plugging in 1/2, arctan of 1, what comes out? Where is tangent 1? Pi over 4. So this is going to be a times pi over 4 plus b. And the other side where we need it to glue together, plugging in 1/2 here, e to the 2 times 1/2 minus 1, that's e to the 1 minus 1, which is e to the 0, which is 1. All right, all of that, 1 minus 1 is 0. So this is one equation that we get from being continuous. end of showing work. I'm not done grading the tests, but I think of the 40 that I've graded so far, 2 of you wrote something that made it an indication of, hey, here's my derivative in a sensible way. The rest of you just kind of barked math floating around on the paper. Please label what you're doing. Show logical work. Bark. It was bad. All right, the tan inverse pattern. Okay, it's 1 over 1 plus stuff squared times the derivative of stuff. And that A was there, it's still there. The derivative of B is just a constant, so that's gonna be just there. And that's at a half. Okay, yeah. This, sorry, I forgot, we haven't done E yet. Okay. My bad, that's coming up tomorrow. Derivative of E to the stuff.
All numbers are what?
Does anybody know?
The same thing.
The same thing. Okay, well, that means the derivative of e to the 2x minus 1 is e to the 2x minus 1. And like everything else, chain rule, what's the derivative of that exponent? What's the derivative of 2x minus 1? 2. So for the derivatives to be equal, now plug in a half. And that needs to equal the other side. So 2a over 2 equals so I got A. Did I get the answer? No. Who? What do we have to do to actually get B? Plug in A and go from there. All that mess. This equation. And the continuity. But can we look at number 3 for a second? Are they asking us to do like sine A plus B and expand it out and do all the nasty stuff? Sita, what are they asking us to do?
They're asking you to find the derivative of, inverse sine x at 4 over 5.
So this is how they're gonna ask you limit definition of derivative. They're not going to ask you to do it. They're going to ask you to recognize the pattern, f of x plus h minus f of x over h as h goes to 0. Ask you to recognize it, see what function it's doing. It's doing the derivative of sine inverse. Where is it asking you to evaluate it at? 4/5. So, Ella, what's the tangent or sine inverse derivative pattern? Begins with S, so. Begins with S, so it's got a squared and a subtract and a square root. And you learn sine first. So, it's gonna be that. Nathaniel, how do I plug in the 4/5 then?
Just do B 0 because the derivative of 4/5 is 0.
Okay, all right. Good point. We're you're doing the derivative of x, like it's a moving target, doing the derivative with respect to x first. And now we're saying, stop the film, stop the action at this spot. So if you plugged in 4/5 up here, you're gonna get a number and the derivative of a number is 0, you're right. But I'm asking you, roll tape, make it go, and then stop and say what's happening at 4/5. So now I'm gonna plug 4/5 in for x. 1 minus 16/25 is 9/25. What is the square root of? Did I lose you guys? Yeah?
I thought because of chain rule, you then have them multiply by the derivative of what was like inside the parentheses.
Okay, the thing that's inside the parentheses, like all of this is asking you to recognize that it's sine x. So the derivative of x, chain rule of that, is 1. So again, we're having it move in terms of x and doing the derivative with x in there, and then plugging in a square moment. There were some math issues in grade, did everyone take the test, by the way?
How the graph relates to everything.
What's the derivative of I mean,
Yeah, that one's easy. That's good enough. That's that on there. Yeah, plus we just like.
Is that legal? No. So don't do that. Natalie, what is the derivative of x squared? 2x. Sadie, what is the derivative of 2x squared? 4. Amelia, what is the derivative of 1/2 x squared? Sorry, what?
1.
1.
The x. Oh, x.
Okay, the number of you that, you could do this fine, you could do this fine. This one, because it was written on the paper like this, you did quotient rule. And it was long and painful, and many of you did it right. However, you wasted a lot of time. You could do quotient rule, please don't. Please realize this is just power rule. Multiply by the power, lower the power. It is also true and those of you who wrote y prime here, don't do that. Y prime is generally dy dx. When you're doing the derivative of parametric, dy dt. This one, again, don't do quotient rule. It is a fraction, but it's just a constant on the top. Multiply by the power. Lower the power, and you're done. Like, you wrote out so much work, and some of you got your negatives flipped around, or did, t cubed squared, and you got that it was t to the 5th, rather than t to the 6th, like, you did interesting things. And there's a new thing I haven't seen that you guys do. You go straight to writing an answer. What is X? Okay, so it's not that fast. Okay, how do you solve for X? Factor. Okay, factor. So what are your two answers? X is 0 and X is a half. So some of you are going from here to just writing answers. And some of you have just written one of them and you dropped the other. You're not showing any factoring at all. I don't know, this is across all 5 of my classes. I don't know where you go, I'll pick this up, but stop it. Show me the work that you're factoring. This is a simple one, and yes, I still want you to show me that you can factor. Because the number of you that will get this right as a fraction, some of you are gonna tell me it's 2 when you just do it in your head, rather than a half. Like, I don't know, were you taught this in Algebra 1, just like me? I do factoring by Zen, but I still factor. I like factoring by Zen, it's good. Alright, these are concerns. So the homework is finish the textbook stuff and this worksheet. Were there other questions from the worksheet that you guys wanted to talk about? 5? 5 is juicy.
That's all I've got.
Okay, this is pretty classic AP. Guys, f of g of x, is that product rule or chain rule? Chain rule. A number of you on the test did this as product rule. There is no partial credit if you try to product rule a composite function. The derivative pattern. Derivative of the outside, leave the inside alone, then multiply by the derivative of the inside. There is nowhere else in this thing that I can get a thing that has g prime. I'm supposed to solve for g prime. Okay, well that equals the derivative of this. The derivative pattern of that, 1 over 1 plus the stuff inside squared, and then be careful, this is like a big mistake. Chain rule, what's the derivative of 1 minus x? Negative 1. Okay, now we want a g prime of 0. Okay. G prime of 0 is going to be negative 1, 1 plus 1 minus 0 squared. Oh, that's not so bad. And I need to divide by f prime of g of 0. G of 0 is 3.1. How do I find f prime of 3.1? It's not the y value, it's the slope of this straight line that you can count the boxes. Down 2 over 1, negative 2, I believe. Yep.
How did you get from the, like, I understand.
Here.
That part to there.
Solve for g prime. So
Okay.
just divide by that ugly thing.
Okay.
I didn't have to, but it's an option.